finding the average rate of change with equations. So let's pretend for a moment. Let us pretend. And I'm going to change the color just because I know you want something better. Look at this graph to the left here. We're going to verify our work. But let's say I told you find the average rate of change of the function f of x equals x squared on the interval 0, 2. Okay. Now, again, whenever you see brackets like this tells me x1, 2, x2. So first thing I need to do is I need to translate this. y1. And let's go ahead and do x2, y2. Okay. Well, my x1 is 0 and my x2 is 2. Now let's pretend. Now you can look at the graph and get them. Let's pretend I didn't give you, that I didn't give you the graph. Well, how would you do this? Well, you have an equation here, right? And when you put the x value into here, it'll get you the corresponding y value. And that's exactly how we can get these 2 points here. So let's go ahead and do that. We're going to get f of 0, plugging in 0 into my function is equal to 0 squared. Well, 0 times 0 is just 0. So I know my y value is 0. Let's go over here and do f of 2 is equal to 2 squared. Right, just x squared. Well, it's positive 4. So go ahead and put positive 4 there. Okay, now that I have my corresponding values, we can do rise over run. Okay, y2 minus y1 over x2 minus x1. Well, y2 is 4 minus 0 over 2 minus 0. And we get 4 over 2, which is 2, or 2 over 1. So my average rate of change is 2 over 1, or just 2. I put the over 1 because we're talking about slope, and you can verify it. Go to 0, 0, which is right there, and then go up to over 1, up to over 1, and we get the average rate of change between these 2 points there. Let me draw that line slightly better. Okay. Boom, there it is. And so that's how we can, approximate, determine the average rate of change from a function. In a scenario where it's not a straight line no more, and this is where it's going to be useful to use the equation. So without having the graph, let's go ahead and do a couple of these problems right here. Determine the average rate of change of the function g of x, square root of x plus 3 from brackets 1, 6. Again, I cannot stress. This means x1 to x2. So let's go ahead and write. I want to translate this. x1, y1, and x2, y2. Well, my x1 is 1, my x2 is 6. How do I find my y values for these? Well, plug it into your function. So g of 1 is equal to the square root of 1 plus 3, which is the square root of 4, which is 2. So let's put 2 here. And over here, g of 6, plug it into the equation, 6 plus 3. And we get the square root of 9, which is 3. So let's put 3 in here. So how do we compute this? Well, now that I have my corresponding x1, y1, y2, well, let's just go ahead and use our slope formula, average rate of change. So y2 is 3 minus y1 is 2 over x2, which is 6 minus 1. We get 2 over 5. So I can conclude my average rate of change of this function is 2/5. And there it is. Okay. Well, let's go ahead and take a look at maybe a more complicated one over here involving the unit circle, just to refreshen our skills. So here we go. Determine the average rate of change of y equals cosine of x on the interval bracket 0, pi over 2. This is average rate of change. I just abbreviated it. All right. And now remember, cosine is the x value on these portions here, right? And we'll look through the radians to determine where. So let's go ahead and do this. So x1 to x2. I'm hoping you're getting the pattern, my friends. Let's go ahead and write this. We're going to get x1, y1, x2, y2. We're going to get 0, and we're going to get pi over 2. Okay. Well, what do we get the corresponding y values? Well, my friend, we plug it into our equation. Y is equal to cosine of 0. Y is equal to cosine of pi over 2. Cosine of 0, well, 0 is right over here, and cosine is the x value, so the x value is 1. So let's go ahead and plug in 1. Cosine of pi over 2, well, pi over 2 is right here, cosine of pi over 2? Well, cosine is your x value, so it's 0. So we get 0. So we got 1, 0. Now we can do rise over run. And we're going to get y2, which is 0 minus 1, over pi over 2 minus 0. And we get negative 1 over pi over 2. Okay. And we can simplify this further. For now, I just want you to practice setting this up. We'll talk about this later. So there it is. Boom. So why don't you practice? Try y is equal to sine of x on 1 comma on oh, did I say 1 comma 6? That doesn't make any sense. We're gonna do this on the interval pi to 2 pi. How about that? Okay. All right. Well, this tells you x1 to x2. So go ahead and do this problem. Let's go ahead and set this up. x1 comma y1 and x2 comma y2. So let's go ahead and set this up properly. This is pi and this is 2 pi. Well, to get them, what do? Well, you plug them in. Sine of pi is equal to and sine of 2 pi. Sine of pi, well, sine is your y value. So if you go to pi, well, sine is your y value, which happens to be 0. So let's plug in 0. And sine of 2 pi is right here. Well, sine is your y value. Well, 0. All right. So now if we go to do this, we got, put that there, rise over run. And we get 0 minus 0 over 2 pi minus pi. So pretty much we can anticipate this then to be 0 over pi, which is 0. Okay. Now here's the thing. Because we get an average rate of change of 0, you can expect probably if you got some kind of sine curve, I don't know, I probably should know this, but whatever. You probably got something that here's, let's say that this is pi, and let's say that this is 2 pi. Well, if you calculate the average rate of change, it's just a straight line. So you can probably anticipate if we were to look at it and you were to graph this, we should probably get 0, something like that. More realistically though, I guess with sine, it would really be, if you were to kind of sketch this through, etc., you would pretty much get from here to here, right? But kind of visually hard to see. So that's kind of what you would kind of maybe expect. Not necessarily 100% true, more of a cosine graph, but you get the picture. With that being said, my friends, that concludes our video.